All right, we're back with example 2 from Advanced Algebra 9.1 on exponential growth, where we have the speed of a supercomputer is measured in teraflops, or trillions of floating point operations. I have no idea what any of these words mean, but we know it's the speed of the supercomputer, and it's measured in teraflops, or trillions of floating point operations. So computer science folks can kind of sort that one out and make sense of that. 2005, the Blue Gene /L, I don't even know if that's how you say that thing, but it looks like it's the name of the supercomputer. That recorded a speed of 280.6 teraflops. So in 2005, this computer had this speed of 280.6. And over the last 30 years, the speed of the fastest supercomputers has been growing at about 78% per year. So the computers have been getting faster as the years go. I get that. And it's been the speed has been increasing by about 78% per year, which is pretty substantial. It's almost doubling. And we're going to suppose that this growth rate continues. Let's just assume that every year the computer gets faster by 78%. And we're going to let C of x be the speed in teraflops of the fastest supercomputer x years after 2005. So 2005 is kind of our new starting point here. And every year, 78% increase in the speed as we go. We're going to write a formula for C of x, or the speed in teraflops. Well, we have a starting value, 280.6. We have to start somewhere. And then we have this growth factor of 78%. When we put this into an exponential function, because it's increasing by a rate of 78%, so we have a multiplicative trend here. What this is going to look like is 280.6 times 1.78 to the x power. 280.6 is the starting amount. That's what we started at. Now, every year, it's increasing by 78%. So we're going to multiply this by 78% and then essentially add that on. But notice we have this 1 here, 1.78. We have a 1 here because if we multiply 1 by 280.6, that's going to stay the same. And then we're going to multiply that by 0.78, which will add on the 78%. So this function here models the speed after x years, after 2005, of the speed of the fastest supercomputer, assuming that this trend continues or had continued. So this is our function here, and it's an exponential function because the speed of the supercomputer is increasing by a percentage, which is where the 0.78 comes into play. Now we're going to use the formula to predict how long it will take for the fastest supercomputer speed to double the Blue Gene /L record to 561.2 teraflops. So we want to know, well, if this continues, how long is it going to take for the speed to double? So we want to find out what does x need to be so that the value is double the 280.6 or 561.2. So we're going to have to solve this equation here. 561.2 equal to 280.6 times 1.78 to the x power. Much like example 1, we're kind of in a position to where we're not exactly sure how to solve this equation. We don't have the tools at the moment. We would need to use a CAS and just put it in as solve, but we don't have the tools to do this at the moment. So this is the equation we're going to need to solve for, and we're going to hang on to that one because x is going to tell us how long it's going to take, but we can't solve that at the moment. So we're just going to sit on that because we're not using a CAS, and then we don't have any other methods at the moment to solve for that. Next one will be same kind of problem. Predict how many more years it will take for the fastest supercomputer speed to double again to 1,122.4 teraflops. So I have to essentially solve this equation now. 1,122.4 is equal to 280.6 times 1.78 to the x power. I want to find out what x is such that this equation is true. How much time has to go by since 2005 to get this speed? Once again, we have the variables and exponent. We're not really in a position to be able to solve for that. So we're going to kind of sit on these two equations. But what's important to note here is that these two equations will give us the values that we're looking for. But at the moment, we don't have the tools to solve for this variable x. So we will come back to these equations.